So transistors are used to amplify current by taking in the small voltage of energy and giving a larger output of energy. Their most popularly and commonly used transistors are BC547, 2N2222 and BC557. The transistor can be used for the voltage regulation, for amplification and for switching purposes. Different types of transistor with us. First one is small signal transistor, which is used to amplify the signal. The value printed on this transistor indicates the gain of the transistor. The gain value also shows the capacity of the transistor to amplify the signal. So higher the gain, higher is the amplification capability of transistor. The common value of gain for this transistor is 10 to 500 and it operates on a frequency range of 1 to 300 megahertz. Its basic applications are as a switch in general purpose circuits, an LED diode driver, relay driver, audio mute function, timer circuits, infrared diode amplifier and bias supply circuits. Next we have small switching transistor. They are basically used as switches but sometimes as amplifier also. If the gain of this transistor is 200, then they are not very good amplifier. So at this gain they are used as a switch. Their gain value range from 10 to 200. They are most commonly used in the switching applications. Next we have power transistor. As you can see, it is made up of metal and this casing is basically the collector of the transistor. So it is used as a heat sink to dissipate the excessive heat generated by the transistor. Operating frequency range of this transistor is from 1 to 100 megahertz and it can handle power of 10 watt to 300 watt. The name of the transistor itself indicates that the power transistors are used in the power applications. They are used for the high power amplifiers and power supply. They are used where high power and high voltage and high current are required. Next we have high frequency transistor. We also call them radio frequency transistors. They are used for the high frequencies and these are used in the high speed switching applications. Maximum frequency is about 2000 megahertz. They are mainly used in the applications of high frequency signals and also these transistors must be on off at a very high speed. These transistors are used in high frequency, very high frequency, ultra high frequency, CATV and MATV oscillators and amplifier circuits. Next we have phototransistors. These transistors operate according to the light. If lights fall on them, they will operate. Otherwise, they will not operate. As you can see, their base is very sensitive to the light. So when lights fall on it, this transistor gets on. The phototransistor have only 2 terminals instead of the 3 terminal. When the light sensitive area is dark, then no current flows in the transistor and transistor is in the off state. Now in this diagram you can see the different shape and sizes of the transistor. So this number 1 we have BUH515 transistor. It is a very high voltage, high power NPN transistor and it is very fast switching speed. It is used for the switching purpose. It comes in an ISO Watt 218 package and it was originally designed for the analog TV but also used in the switch mode power supply. Next we have 2N3055. This transistor, this is an NPN silicon power transistor of 115 watt. It is designed for the switching and amplifier applications and it can also be used as one half of the complementary push-pull output pair with PNP MJ2N55 transistor. Next we have this one. This is a 2N2219 NPN silicon transistor. It comes in a metal case and T039 package, designed for high speed switching and for amplification at frequencies of 0 Hz to 500 MHz. Next we have this number 4 transistor, which is 2N6487. It is a general purpose NPN output transistor with a power rating up to 75 watt in a TO220 package. Next we have this number 5, BD135 and BD136, and it is a complementary NPN PNP push-pull transistor. It is used for the low medium power audio output systems. Next we have this 6 number transistor, small signal general purpose transistor. All three are the small signal general purpose transistor, 2N2222, 2N3904. These are commonly available in a variety of package types such as T018 metal case package, as you can see in this figure 6, and the cheaper plastic version is also available, T092, for through hole mounting on the printed circuit board, as well as surface mount SOT23 version is also available, as you can see here in the image 8. Now you can identify the base, emitter and collector of a transistor with the help of this table. Transistor comes in different package versions, so according to their packaging, their emitter, base and collector changes. Here you can see we have 3 leads in a transistor, 1, 2 and 3. So for 2092 package, the pin number 1 is for emitter, pin number 2 is for base and pin number 3 is for collector. And it is same for T094 package also, but for T096, first number pin is base, then emitter and then collector. And for T097 and T098, it again changes. The first pin becomes the collector, then base and then emitter. So the terminal depend upon the type of the package used for the transistor. Identify the transistor terminals with the help of multimeter also. Here you can see in this diagram, we have a PNP transistor D83004, and here you have the internal diagram of this PNP transistor. Internally, 2 diodes are connected to it, and we can see this is the anode terminal and this is the cathode terminal. The cathode of or N side of both the diodes are connected together to this metal casing, which is acting as a base here. So we have N-type base and P-type collector and emitter. So to check this with the help of multimeter, what we have to do, we touch the red probe of the multimeter to the collector and black negative probe to the base. Now as you can see, the collector is of P-type and base is of N-type. So when we connect positive probe to the P-type collector, it should show a very low impedance and it will show some voltage drop, some forward voltage drop. Okay, and it will get forward bias. This diode will get forward bias basically connected at the collector terminal, because we are touching the positive probe to the anode terminal and negative to the cathode terminal. So it will get forward bias and the multimeter will show some forward voltage drop here. So if it is showing a forward voltage drop, then it is correct one. And you can identify then this is collector of PNP and this is base. You can also check it by reversing the direction. Now connect the negative probe, black lead, to the emitter and red knob to the base. Now as you can see, we have connected the positive terminal with the negative base. So it will reverse bias and it will not show any forward voltage drop. Instead it will show 1. 1 means infinite resistance or the polarity is not correct. So in this way we can also check the polarity of the different leads of the transistor. We can identify the emitter, base and collector likewise. But this method can only be used when the transistors are correct. They are good. We can also check the transistor gain with the help of the multimeter. Here you can see we have a multimeter and here we have a point HFE. HFE is the DC gain of the transistor. So by rotating the knob to this position, we can check the gain of the transistor. And in this diagram you can see we have a small socket to insert the transistor here. So here we have 2 types of connection, NPN and PNP. So you can refer to the data sheet or you can check with the multimeter whether the transistor is of NPN or PNP and then insert it. or you can insert randomly also without knowing whether it is NPN or PNP. You can directly insert the transistor in this socket, but you have to keep it in mind. Then you should insert emitter lead to the emitter terminal only. You can see here emitter collector base is mentioned. So you should insert the emitter lead to the emitter socket only and insert it properly. Once you insert it properly, you will see the gain value in the display bar. So here you can see for BC549C transistor, we have gain 500. Theoretically, its value is 500. The meter is showing 518. So it is okay. Little up or down is okay. So this transistor's gain is 518 and it is a NPN transistor. If you would have connected it to the PNP side, it would not have shown any reading. So it means it is not correct. It is not PNP type. Then insert it in the NPN socket, and when you insert it in the NPN socket, it will show you some reading. So it means it is of NPN type. So in this way you can check two things. You can check the gain of the transistor. You can also check whether a transistor is of NPN type or PN type. Next, let's see how to read the values on the transistor. So you must have noticed there are some number, alphabets and digits written on the transistor. So the first number, if the first number is 1, it means the component is a diode. As you can see in this diagram, the first digit is 1. So it means it is a diode. If the first digit is 2, it means it is a bipolar transistor or FET. So as you can see in this diagram, 2 is written, and in this diagram also first digit is 2. So it means it is a transistor. And if first digit is 3, it means it is a dual gate field effect transistor. So in this way, by reading the number and alphabets written on the component, you can identify its type. Second letter is N, and then there is a serial number, which is the identification of a component. Here you can see we have an NPN transistor BC548. So we can also identify the terminal very easily. This flat side, keep this flat side towards you, and the extreme left lead of the transistor is collector, the right hand side is emitter, and middle one is base. So generally we have this type of leads. Left one is collector, middle one is base, and right one is emitter. But again, this leads identification changes according to the package also, as we have already seen. Now here you can see we can identify according to the letter also. If the first letter is A, it means this transistor is of germanium. If first letter is B, as it is here in this diagram, it means this transistor is of silicon. C, then it is gallium arsenide, and if R is written, it means it is of compound material. It can be a mixture of all this material or any two of it. Then we can identify the second letter, as in this diagram the second letter is C. So it means this transistor is basically it can work on audio frequency, or it is a low power transistor. So similarly, by reading the second letter, you can identify the type of transistor or its operation.